Hello everyone, welcome back to my channel. In today's video, I am going to explain you how to write IUPAC name of organic compound. So stay tuned with me till the end of the video for a better understanding. So let's start it. IUPAC nomenclature. So in this video, I'll explain you how to write the IUPAC name of an organic compound. So let's start this. So if you see that what are the general things we generally follow, the pattern which we follow to write the IUPAC name of a compound is, first we write the prefix, okay, prefix, then we use the word root, after this we use primary suffix, and lastly we use secondary suffix. Okay, so in the IUPAC name of an organic compound, we need to follow this sequence, right? So now let me explain you one by one the meaning of all these terms. Now if you have a carbon chain, suppose you have an organic compound like this, suppose this is CH3, CH2, here you have one group, okay, now the group is, suppose you have CH3 group attached to this, okay, then CH, single bond CH3. If you are writing the IUPAC name of this compound, in this compound, if you see, this is the straight chain of 4 carbon, and this group, right, this group is actually, we are not, when I am giving the counting, right, when I am giving the counting, I am able to take the carbon chain of maximum 4 carbon in as a continuous chain, right, but I am not able to give numbering to this particular carbon. So the carbon which we are not able to number is considered as, or the group which is attached as a branch on the main chain is known as a substituents, right, is known as a substituent, and these substituents are basically known as prefix. Okay, these substituents are known as prefix. So first we always write the position of the suffix along with its name, position of the prefix along with its name. Okay, second thing is your word root. Now let me tell you the meaning of word root. What is the meaning of word root? Word root basically defines, that in the given organic compound, how many carbon atoms do you have? Suppose if you have one carbon chain, the suffix we use for one is your meth. If you have 2 carbons in a chain, then the suffix we use is eth. 3 carbon we use prop. Then if you have 4, we use but. If you have 5 carbon, then we use pent, and if you have 6, we use hex, and so on. Okay, so for 7 you will say hept, 8, oct, like that. In 10th grade, right, till 10th grade, we have, whether it is ICSE board or CBSE board, we do not have organic compounds, right, carbon containing chains or the compounds for nomenclature more than 6 carbon. Maximum 6 carbons questions can be asked to you in board exams, not more than that. So first 4 is basically important for us to remember, because that is a different thing, right, eth, meth, eth, prop, but. But if you see 5 and 6, it is just like in you do in mathematics, right? For 5 you will say pent, 6 you will say hex, then 7 you will say hept, 8 you will say oct, like that. Okay, so this is called word root, which defines the number of carbon atoms. Now if you see primary suffix, what is primary suffix? A primary suffix is basically, you need to check that in the given compound, how in the carbon chain, how the carbons are connected to each other. If all the carbons are connected with single bond, we use the word root we use the primary suffix "-ane". If you have 2 carbon atoms connected through a double bond, we use the primary suffix "-ene", and if there are 3, right, if there is a triple bond between 2 carbon atoms, then we will use the primary suffix "-ine". Okay. Now what about your secondary suffix? Secondary suffix basically defines the functional group present in the organic compound. Functional group present in the organic compound. Okay. So now let me introduce you with all the functional group which we have in our grade 10th syllabus, whether it is ICSE or ISC or CBSE syllabus. So I'll just explain you what all functional groups do we have to study, and how to name them as a secondary suffix. Okay, so let me first introduce you with various types of functional group. Okay, so now I am making a table here: functional group, functional groups, their names, the names of the functional group and the suffix we use for them. Okay. Now, let me show you the table. Look at in this table. So, functional group, the first functional group which we will use, that is X, where X is representing a halogen atom. It can be chloro group or bromo group, right. So, if you have such type of functional groups present in the organic chain or organic compound, you will name them as halo compounds. You will say halo, okay, and the suffix we use for them, that is known as your halo, right. Like if it is specifically chlorine, you will say chloro. If it is bromine, you will say bromo. Okay. These are the suffix you will use. Now, if you have this group present in the compound, in the carbon chain, if this group is present, such compounds are called alcohol. What do you call such family? Right, alcohol, and the suffix we use is all. Okay. I will tell you that how to use this suffix. You just see that what are the functional groups we have, what is the name of that family, and what is the suffix we use for them. The third functional group we have CHO. What is CHO? CHO is your aldehyde. Okay. So, if any compound in any carbon chain, you will find this type of group. In short, this group is also written as free valency CHO. Okay. In short, I just mentioned the expanded form. So, you will say that this type of compounds are called aldehyde, and for aldehydes we use the suffix al. Similarly, the next functional group which you have, that is this group C double bond O OH. Now, what is that functional group? This is called your, in short, sometime we write it in the or we can write it. In short, we can write it COOH group. You can easily recognize this group. This group is called your carboxyl group. Okay, carboxyl group, or also known as carboxylic acid. Anything which will have this group present in them, such compounds are called carboxylic acid. Okay, and for carboxylic acid, what is the suffix we use? We use oic acid. Okay. Now, one more functional group which we have in our syllabus, that is ketonic functional group. I will show you this functional group, where you will see that I will show you that if you have carbon attached with double bond O and both side carbon is attached with any carbon chain. Okay, this side you will have any carbon chain, then this group is called ketone. This compounds which will have this type of carbonyl group present in them are called ketone. Okay, and the suffix we use for them is -one. We will not read it as one, we will read it as -one. So, these are the suffix which we are going to use. Okay. So, once again I will just show you that what all functional group I discuss. I discuss the first functional group is as your, the first functional group is your halogen, the second functional group is your alcohol, the third one is aldehyde, the fourth one is acid, and the fifth one is your ketone. So, this is called your secondary suffix. Now, let us some examples. Okay. So, again one more thing before I will go for an example, I will tell you one more thing. Okay. Now, if you have, see, general formula, right, how to present an alkane generally, we write RH. R is representing an alkane. Okay. RH is representing an alkane, right. If I will remove this hydrogen, what will left behind? R free valency, right. How will you read it? You will say R free valency. This is called free valency. That is how you should read it. RH, if you are removing this hydrogen, if I removed this hydrogen, what will left behind? R free valency. What do you call this group? From alkane. Now, the new group which you are getting, we will say this is called alkyl group. Okay. Now, let me give you one example. I have methane. Look at this. I have methane. Okay. Now, I can write methane. I am writing in this way. Look at this. I am writing CH3 dash H, that is same thing. This is my condensed structure CH4. Okay. Or I can write it like this, or I can write like this. Now, I am removing this hydrogen. So, this is your methane. When you removed this hydrogen, then what will left behind? You will get CH3 free valency. What do you call this group? See, whether we write CH3 free valency like this, or if I write like this CH3 free valency, doesn't matter, okay? Though these two are same thing. You can write CH3 free valency or CH3 free valency. What do you call this group? This group is called, like alkane gives us alkyl group, so methane will give us methyl group. So we are going to use this group in many places. So if I ask you what is the name of this group, you should be able to recognize that CH3 free valency is a methyl group. Now take the name. So if methane, if you remove one hydrogen from methane and you are getting methyl group. Similarly, if you have ethane, what is ethane? C2H6. If you are removing one hydrogen from ethane, what will you get? C2H5 free valency. What do you call this? If this is methyl group, then this will be ethyl group. This will be ethyl group. Similarly, if you have C3H8 and you remove one hydrogen, what will you get? C3H7 free valency. How will you read this group? You will say propyl. Okay, so and so on. So once again, alkane is giving you alkyl group by the removal of one hydrogen. Similarly, methane will give you methyl group, ethane will give you ethyl group, propane will give you propyl group. So keep this in mind, and keeping this in mind, let us start few examples explanation. Okay, so we'll take one example and I'll explain you how to write the IUPAC name of a compound. Okay, now see this one. So I have taken one example here. Suppose I am asking you, write the IUPAC name of this compound. CH3, CH2, CH. Here we have CH3 group attached to this. Then again CH3. How will you name this compound? How will you name this compound? So the first rule for naming the compound is you need to select the longest chain. Okay, what did I say? The first rule is to select the longest continuous chain of carbon atom. Right, longest continuous chain of carbon atom. So what is the meaning of longest continuous chain? Now if I will ask you to count the carbon, you cannot say there are total 5 carbon which we can count continuously. If you will go this way, 1 2 3 4, you are able to count only these 4 carbons continuously. You are not able to count this carbon, right? So what is the longest chain I am getting? 1 2 3 or 1 2 3 4 we are getting. This is, so we are, see, we have two chain. You can say we can count this way or we can count this way. So can you tell me that which chain is longest, the green one or the blue one? Right, so the blue one is the longest chain. You can see in blue one I am having total 4 carbon atoms. 4 carbon I am able to count continuously, whereas in the green color I am able to count only 3 carbon atoms. 3 carbon atoms. So I will go for my blue chain. Okay, so I am going for blue chain. So look at this. If we are taking the blue chain, right, let us give the numbering. Now while giving the numbering, what we should see, that we should start the numbering. Now there are two possibilities, whether you will write the numbers like this 1 2 3 4, or will you write the numbers like this 1 2 3 4, which is the correct numbering. So this is the correct numbering, but this one is the wrong numbering. Why? We should start the numbering from that end, from where our functional group is nearest, or where our, like when we are selecting the longest chain, right, the functional group, or you can say from where the chain or the branches are getting, or the substituent. I told you, know, what do you call them? These are the branches which are hanging to the main chain are called substituent. So we will start our counting from that end, from where our substituent is getting the least possible number. So when I am counting in the this way, that red line, right, reading, you can see that we are getting the substituent in second position, but if we are following the blue color, we are getting in the third position. So we will go for the least possible number. We will go for the red numbering. Okay, so this is the numbering. Now what I said, that what is the sequence we should use to write the IUPAC name of a compound? I told you we will use the prefix, then word root, okay, then word root, then primary suffix, and lastly we use the secondary suffix. Okay. Now what is the primary suffix? Prefix. Prefix is the substituent. Now what is the name of this substituent? This CH3 is called a methyl group. this substituent methyl group. This is your methyl group. Now which is attached with, I told you, CH3 free valency is named as methyl group. So this is your methyl group, and it is attached to which carbon? 2. It is attached to 2 number carbon. So first you will write its position 2, and whenever we write any number and word, we use the hyphen dash sign between the number and the word. Okay, so it will become 2 methyl. Now what is the word root we have? Word root means total 4 carbon. So you will say but. For the 4 carbon we use the but word root. Okay. Now primary suffix means, right? Now primary suffix means you will say that whether it is, I told you primary suffix is with ane, ene, ine. You need to see that is there any double bond between carbon or single or triple. So we have all the carbons which are connected through single bond. So we will say the primary suffix will be ane. Now we do not have any secondary suffix in this particular compound because secondary suffix is the functional group. So we do not have any functional group. So we will not use any secondary suffix. So just club them, merge them together. What will be the name come out? 2-methyl butane. 2-methyl butane is the IUPAC name of this compound. So that's all about today's video. Hope you enjoyed the video and understood the concept very well. But if you still have any doubt, please do write in the comment section. I will definitely reply as soon as possible. I will really appreciate if you can subscribe my channel and like my video. Thank you.